Hello guys, in this video, you'll first understand the basics of Arduino hardware board and then you'll install the Arduino IDE. Next, you'll look at the parts required for building the robot and then construct a car robot. After this, you'll write the Arduino program to move the robot in forward, backward, left and right direction. So, let's start with this video by first understanding what is an Arduino. Hey, what's up guys? Welcome to your very first robotics tutorial. Now, in this video, I'll explain you the basics of Arduino microcontroller as we will use it for our programs. So, Arduino is an open source hardware board which is used by electronic hobbyists, artists, designers and even electronic newbies for building projects related to electronics. Since it is an open source hardware board, the design files of Arduino are made publicly available online by its developers. The Arduino IDE, that is Integrated Development Environment, uses a simplified version of C++, thus making it easier to learn programming. The Arduino board generally consists of a USB connector, a DC jack, Atmega microcontroller, crystal oscillator, voltage regulators, reset switch, etc. And it can interact with components like buttons, LEDs, speakers, GPS units, cameras, internet, and even your smartphones. The Arduino board that you're seeing right now is the Arduino Uno and it is one of the easiest Arduinos to get started with. Now, for explaining the Arduino Uno, I'll first divide it in 6 different parts. You can see these parts in front of your screen. I will start explaining from this top left part over here. I basically call this part as the communication part. This part mainly consists of a USB connector, a reset switch and an Atmega 16U2 chip. The Arduino board requires 5 volts of power for operation, and when we connect the Arduino to a laptop or to a computer using the USB, it gets that required 5 volts. Programs are uploaded from the laptop to the Arduino using this USB. Neighboring to the Arduino, there is an Atmega 16U2 chip. This chip is basically used for USB to serial conversion. On the top, as you can see, the Arduino consists of a reset button. We can use this button to reset the Arduino. Now, if you look at this part over here, which is on the lower left side, then this part is called as the external power supply part. This part consists of a DC jack connector and a voltage regulator. So guys, after uploading the program in the Arduino, if we want to give external power supply to it, then we can provide external power using this DC jack connector. We can supply external power between 7 volts to 12 volts using a battery or an adapter. The maximum supply that we can give is around 20 volts. The Arduino also consists of a voltage regulator which converts higher voltages to 5 volts. So even if you supply an external voltage of more than 5 volts to the Arduino, the voltage regulator is the one that reduces the voltage to 5 volts, thus protecting your Arduino from higher voltage damages. Next, let's talk about the Arduino microcontroller board. The Arduino Uno consists of an Atmega 328 microcontroller. The Atmega 328 is a 28-pin microcontroller, out of which 20 pins are data pins. Out of these 20 data pins, 14 pins are digital data pins and 6 pins are analog data pins. We can use the data pins either as input or as output. Some technical specifications of this microcontroller are: it consists of a flash memory of 32 KB, SRAM of 2 KB, EEPROM of 1 KB. The Arduino board also consists of a 16 MHz crystal oscillator. And as I told you earlier, the Arduino board consists of 14 digital pins which are labeled from 0 to 13. If we look at pin number 0 and 1, then over here RX and TX is written, which stands for transmitter and receiver. So we can basically use pin number 0 and 1 for serial communication, that is for communication between a Bluetooth, GSM or even your computer. Now if you look over here, the Arduino consists of a transmit and receive LED. These LEDs will blink when we upload the program from the computer or whenever a data is transmitted to the Arduino. The LED above the transmit LED, which is labeled as L, is internally connected to pin number 13 of the Arduino. So we can control this LED by writing a data on pin number 13. An Arduino consists of 6 analog pins which are labeled from A0 to A5, and we can use these pins for connecting analog sensors or analog devices. The analog values that we can plot using the analog pins is in the range of 0 to 1023. Neighboring to the analog pins, we have the power pins. Now, using the power pins, we can supply power to the sensors and other electronic components that run at 3.3 volts and 5 volts. So, as you can see, there is one 3.3 volt pin and one 5 volt pin for supply. The Arduino consists of 3 ground pins, 2 pins at the bottom and 1 pin at the top. The Arduino consists of an on LED. This LED will basically turn on when Arduino gets 5 volts of power either from the USB or from an external power supply. So guys, in this video, I've explained you the basics of Arduino, and in the next video, we will install the Arduino IDE. Hey, what's up guys? Welcome back. This is Dinesh here, and in this video, I'll show you how to install the Arduino IDE. Now, for installing the IDE, I'll first open Google Chrome. You can open your desired browser. Next, I will go to Arduino's official website, that is arduino.cc. After that, I'll click on download. Next, as you can see, on the right side, I have different downloading options. So, if you're using a Linux system, then you can download any of the 3 options from here. If you're using a Mac system, then you can download this link. If you're using a Windows system, then you can download any of the 2 links. So I'll download the first link over here, which says Windows Installer. Next, I will click on Just Download. So as you can see, the download has just been started. So guys, as you can see, the Arduino software is downloaded and I've copied it on my desktop. So to install it, I'll double click on this. I'll click on I agree. Then I'll click on Next. After that, I'll click on Install. So the installation will take around 5 to 10 minutes depending on your system. So guys, as you can see, the installation is complete. Now guys, if you're installing the Arduino software for the first time, then the Arduino software will also ask you to install the necessary drivers. So if you get an option asking installing the drivers, then you just have to click on install. I didn't got that option because I've already installed the drivers before. And once you install the drivers, you will get this option of close. So I'll click on close over here. And next, I will click on the Arduino IDE shortcut to open the Arduino IDE. And guys, IDE basically stands for Integrated Development Environment. So guys, as you can see, the Arduino IDE has been installed in my system. Now, in the next video, I'll show you how to set up this Arduino IDE. Hey, what's up guys? Welcome back. This is Dinesh here, and in this video, I'll show you how to set up your Arduino IDE. Now, before setting up the Arduino IDE, first you have to connect your Arduino to the laptop or to your computer using the USB. After connecting the Arduino to your laptop, next you have to right click on this computer or my PC. So I'll click on Windows, I'll go in File Explorer. Next, I'll right click on this PC, and after that I'll click on Manage. So after clicking on Manage, next I will click on Device Manager. Now guys, after clicking on Device Manager, on the right side you have this option called as Ports. So I will click on this small arrow over here. Now guys, inside the ports option, as you can see, Arduino Uno has been shown here. And to this Arduino Uno, COM3 has been allotted from a laptop. So guys, inside the ports option, you have to check what COM number has been allotted to your Arduino Uno from your laptop. The COM number allotted to my Arduino Uno is COM3. The COM number allotted to your Arduino Uno may be something else, that is COM4, COM5, COM6, etc. So after checking the COM number, next I'll close this, and now I'll open the Arduino IDE. Now inside the Arduino IDE, first I will click on Tools. From the tools, I'll first check the board. So currently, since I'm using an Arduino Uno, I'll basically check the Arduino/Genuino Uno board from the list. If you're using any other board, then you can select the board from the list over here. After selection of board, next you will go to ports, and since the port that was allotted to my Arduino Uno was COM3, so I'll basically select this port. I will again go in tools and check whether it is selected or not. So you can see it has been selected here and it has been also shown over here. And at the last, you just have to verify what is the programmer. So the programmer will be by default set to AVR ISP MK2. So guys, in this video, I've basically shown you how to set up your Arduino IDE. Now, from the next video, we will start with the programming. Hey, what's up guys? Welcome back. In this video, we will write our very first Arduino program, that is the Blink program. Now, if you're familiar to the Arduino programming system, then you would have already written this program before. Inside the Arduino IDE, as you can see, there are two main functions, the void setup and the void loop. Inside the void setup function, we have to declare the pins that we are going to use in the program. Now, in this Blink program, we will blink the Arduino's onboard LED, which is labeled as L. This LED is internally connected to digital pin number 13. So, inside the void setup, I'll first write pin mode 13, output. So guys, inside the pin mode, I have first written the pin that we want to control, and after the comma, I have declared whether I'm using this pin as an input or output pin. Now, I'll be using pin number 13 as an output pin. Now guys, you can also notice that if you have written the syntax correctly, then the text color changes over here. So, for pin mode, the PIN is small, M is capital, and ODE again is small. And if you write the syntax properly, then the pin mode text color changes to orange. Similarly, for the output text, all the text are capital and the text color will change to blue. After declaring the pins, next we will write the program to blink the LED. So to blink an LED, we have to make it high for some time and then low for some time. And we will write this high and low condition inside the void loop. Now, as the name of this function is a loop, the programs written inside the loop function keep repeating itself again and again. So let's write the blinking part of the program. So first, to make the LED high, I will write digital write 13, high. After making the LED high, I also need to specify a time duration for which the LED will be high. So for that, I will write delay, and I'll set a delay of 2000. So 2000 stands for 2000 milliseconds, which is equivalent to 2 seconds. So my LED will be high for 2 seconds. After making the LED high for 2 seconds, next I will also make the LED low for 2 seconds, and for that I will write and then I'll again put a delay of 2000 over here. Now guys, let me run through the code once. Now inside the void setup, as you can see, I have declared pin number 13 as the output. After that, inside the void loop, I'm making the LED 13 high for 2 seconds and low for 2 seconds. And since I've written this condition inside a loop, this program will keep on executing again and again, thus making a LED blink. So guys, after finishing the program, next I will click on compile to check for any errors in the code. So I'll click on this first circle over here. Arduino is asking me to save the program first. So I'll save the program and I'll give this a name of blink. Now after clicking on save, you can see the compilation has started. So as you can see, the compilation is finished, and if you get a message of done compiling, then that basically means your code does not contain any error. After compiling the program, next I will upload the program on my Arduino, and to upload it, I'll click on this upload option. So the program is successfully uploaded. Next, we will check the blinking output. Hey, what's up guys? Welcome back. In this video, I'll explain you how to choose a good robot chassis for building your car robot. Now, you can purchase the robot chassis from online websites like Amazon.com, or you can also purchase this robot chassis from any electronic hardware store. So guys, as you can see, I've already gone to Amazon.com, and after searching for car robot chassis, these are the options that I've got. Now, out of the multiple options that are available, I have opened two results over here. If you look at the first robot chassis, then it consists of one single plate. You can see the transparent plate over here. It consists of two DC motors which are fitted to the plate, and it consists of a small wheel in the front. This is one of the ideal chassis that you can purchase if you are a complete beginner to robotics and embedded systems. Next, if we look at this second chassis, then it consists of one upper plate, one lower plate, and it also consists of a spacer for maintaining space between the upper and the lower plate. But guys, as you can see, this chassis consists of 4 DC motors, and we only have a requirement for 2 DC motors. If you purchase this chassis, then you have to purchase 2 motor drivers as well. The robot chassis that I am using consists of one upper plate, one lower plate, and 2 side plates. The DC motors are basically fitted inside the robot chassis arrangement. I purchased this robot chassis from a robotics store in my city. Now, even though the robot chassis that I am using will be different from yours, the construction of all the robot chassis is almost similar. So after watching the construction that I'll be doing, you will get a clear idea of how to construct your robot as well. Now guys, if you want, you can browse through the multiple robot chassis that are available on Amazon.com, and you can basically choose the robot chassis that best suits your need. So guys, that's it from this video. In the next video, I'll explain you the different components that we require for building a robot. Hey, what's up guys, welcome back. In this video, I'll show you the parts that we require for building a robot. So first, for building the robot, we require the chassis. So the chassis that I have consists of one upper plate, one lower plate, and 2 side plates. Next, we require a screwdriver for building the robot. After that, we will require some screws. The specification of the screws I'll show you in the later videos. One caster wheel, one spacer for maintaining space between the 2 plates of the chassis, 2 DC motors, 2 wheels, 2 DC jack connectors, 2 battery snappers, 1 motor driver, an Arduino Uno, 1 USB, a minimum of 3 to 4 batteries, and male to female wires. So guys, these are all the parts that we require for building a robot. Hey, what's up guys? Welcome back. In this video, I'll explain you what is a motor driver and how to choose a good motor driver. So, a motor driver is a breakout board which consists of a motor driver IC. I am using a motor driver breakout board which consists of an L293D IC. A motor driver circuit board is used for running the motors. It is like a current amplifier, and the main purpose of the motor driver is to take a low current signal and convert it to high current signal so that it can run the motors. The reason why we require a motor driver is because components like motors cannot be connected directly to the Arduino as they do not get sufficient power from the Arduino. So we basically connect the motors to the motor driver first and then supply power to the motors using a battery through the motor driver. Now, since I've taken many workshops on embedded systems and robotics, here are 3 of the motor drivers that I have used. All the 3 breakout board uses an L293D IC, which is a motor driver IC. The L293D IC is a 16-pin IC, out of which 4 pins are input pins and 4 pins are output pins. Pin number 2, 7, 10 and 15 are input pins, and pin number 3, 6, 11 and 14 are output pins. You can also see it consists of 4 ground pins, that is pin number 4, 5, 12 and 13. Pin number 1 and 9 from this IC is called as enable pin, which requires 5 volts of power for operation. Pin number 16, which we can call as VCC pin, also requires 5 volts of supply. And at pin number 8, we need to give external power between 5 to 12 volts. That is, we need to provide external power using a battery or an adapter. Now, since we are using this motor driver circuit to control a robot, we will require a battery instead of an adapter. Now, if you are using just a motor driver IC, then you have to do all the connections by yourself on the breadboard first and then connect the entire circuit to the Arduino. So, instead of doing the entire connections by yourself on a breadboard, it is better that you purchase a motor driver breakout board, as the motor driver breakout board consists of sockets in which we have to connect the input wires from the Arduino, the output wires from the motors, and it also consists of a power supply socket where we can directly give power from the battery. Now guys, as you can see in front of the screen, there are 3 motor driver breakout boards, and in all the 3 motor driver breakouts, you can see that there are pins or sockets to connect the input pins from the Arduino, and there are output sockets to connect the DC motors. There is also a power socket where you can connect the external battery. So out of the 3 breakout boards which are present, I'll first explain you the breakout board which is there on the left hand side. Now if you look at the first motor driver, then it consists of 3 green sockets, 2 at the bottom and 1 at the top. It also consists of 4 data pins on the top left side. The input pins of the L293D motor driver IC, that is pin number 2, 7, 10 and 15, can be accessed from the top left side over here at A1, A2, B1 and B2. To these pins, we will provide inputs from the Arduino's data pins. The 2 green sockets at the bottom are for connection to the DC motors. So, the output pins of the motor driver IC, that is pin number 3, 6, 11 and 14, can be accessed from these green sockets. Each socket consists of 2 holes in which we have to insert the DC motor wires. And you can also see the green socket which is present on the right hand side is used to supply external power to the motor driver using a battery. Now, if we look closely, then there are 2 more pins for VCC and ground. So, at the VCC pin, we had to provide a supply of 5 volts from the Arduino. That is, I had to supply power from the 5 volt pin of the Arduino to this VCC pin. And I also had to connect 1 ground pin to the ground pin of the motor driver. So guys, the disadvantage that I found of using this motor driver is that I also had to give 5 volts of supply from my Arduino to the VCC pin of this motor driver. Now, if we look at the second motor driver over here, then it consists of 5 green sockets. The input pins of the L293D IC are connected to the top green sockets which are labeled as M1 in and M2 in. So, at M1 in and M2 in, I had to connect the inputs from the Arduino. The output pins of the motor driver are connected to the bottom green sockets over here, which are labeled as M1 out and M2 out. So, to these sockets, I have to connect the DC motors. You can also see that there is one more green socket on the right side, and to this green socket, I had to give external power using a battery. The advantage that I found of using this motor driver is that I did not have to give 5 volts of supply separately to this motor driver breakout from my Arduino, because the circuitry of this breakout board is made in such a way that the VCC and the enable pins gets the required 5 volts from the external battery itself. So in short, the motor driver basically converts the incoming supply from the battery and give 5 volts of power to the pins that requires 5 volts. And if you look at the last motor driver, then this motor driver is more advanced than the other 2 motor drivers. It consists of D1, D2, D3 and D4 pins, which are connected to the input pins of the L293D IC. And as you guys would have guessed, these pins will be connected to the Arduino's data pins. The DC motors will be connected to the green sockets, which are labeled as M1, M2, M3 and M4. And I had to connect a battery to the DC jack connector for providing power. The breakout board also consists of an on-off switch, using which I can switch on and switch off this board. Now, like the previous motor driver, I also did not have to give separate 5 volts of supply to this breakout board as well. So guys, when you purchase a motor driver breakout board, please check its specifications and also verify whether you need to provide 5 volts of supply from your Arduino or not. That's it from this video. I hope from this video you would have understood what is a motor driver and how you can choose a good motor driver. Hey, what's up guys? In the previous video, we talked about the motor driver breakout board and the L293D motor driver IC. Now, in this video, I'll explain you the working of L293D motor driver IC. The L293D IC can control 2 motors at a time. It consists of a dual edge bridge motor driver circuit. That is, the motor driver IC consists of 2 circuits like these, one for each motor. Now, before I start explaining you the working of motor driver, let me explain you a very simple concept. So, if suppose you want to determine the number of input or output combination according to the devices you have, then there is a very simple formula for that. For example, in the first section, we have written a program to blink the LED. Now, since we had only one LED, there are 2 outputs possible. First, your LED will be high. Second, your LED will be low. So, from the LED example, let's look at the formula. Now, if you have one digital device, then your N is equal to 1. And the formula to determine the number of input and output combination is 2 raised to N. So, for N equal to 1, there are 2 outputs possible, that is high and low. Now, since we have to control a robot and our robot consists of 2 motors, then N is equal to 2. And so, the combination logic is equal to 2 raised to N, that is 2 raised to 2 equal to 4. So, for 2 motors, there are 4 input combinations possible. And these combinations are 0, 0, 0, 1, 1, 0 and 1, 1. That is low, 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 high, high, low and high, high. And when we apply these inputs to the motor driver from the Arduino, the motor driver will thus control the motors. So now, as you can see, this is an edge bridge circuit and this edge bridge circuit can control one motor. On the right hand side, there is a table indicating the input and output conditions. The input conditions of high and low are given from the Arduino to the input pins of the motor driver. And then from the output pins of the motor driver, the DC motors will be controlled. The edge bridge circuit basically consists of 4 switches S1, S2, S1 bar and S2 bar. And we need to give the inputs from the Arduino to these switches. On the top, there is a VCC pin and at the bottom, there is a ground pin. In the middle, there is a motor. And for this motor to move, the current should pass from VCC to ground. So first, if we give an input of 0, 0, that is S1 is 0 and S2 is 0, then the S1 and S2 switch will be open. Similarly, the S1 bar and S2 bar switches will be closed. So, since the S1 and S2 switch is open, the current will not flow from the VCC to ground, and at this condition, that is 0, 0 or low, low, the motors will stop. Next, if we give an input of 0, 1, that is S1 is 0 and S2 is 1, then S1 will be open, S2 will be closed. Similarly, S1 bar will be closed and S2 bar will be open. So, when we give a condition of 0, 1 or low, high, then the current will flow from VCC to S2, then to the motors. From the motors it will go to the S1 bar, and from the S1 bar it will go to the ground. And in this case our motors will move, but it will move in the backward direction. So guys, at low high the DC motor will move backward. Next, if we give a condition of 1 0, that is S1 is 1 and S2 is 0. So in this case the S1 switch will be closed, S2 switch will be open. Similarly, S1 bar will be open and S2 bar will be closed. So guys, in this case the current will flow from VCC to S1. From S1 it will go to the motors. From the motors it will go to S2 bar, and from S2 bar it will go to the ground. So guys, when you give a condition of high-low, the DC motor will move and it will move in the forward direction. And last, at the condition of 1 1, that is if S1 is 1 and S2 is 1, then in this case the S1 and S2 switch will be closed and the S1 bar and S2 bar switches will be open. So guys, as you can see, this condition basically represents a short circuit condition. So at this condition, that is 1 1 or high high, the motors will not move because the current will not be able to flow from VCC to ground. So guys, if we run through all the conditions again, then at low low the motors will stop. At low high the motors will move, but in the backward direction. At high-low, the motors will move in the forward direction, and at high-high, the motors will stop. Now guys, after understanding the conditions, let's look at a very simple example. If you connect pin number 3 and 4 from the Arduino to the D1 and D2 pins of the motor driver. Similarly, if you connect pin number 5 and 6 from the Arduino to D3 and D4 pins of the motor driver. Next, if you connect the M1 and M2 socket of the motor driver to the left motor, and if you connect the M3 and M4 socket of the motor driver, then when you write any command on pin number 3 and 4, the left motor will be controlled, and when you write a command on pin number 5 and 6, the right motor will be controlled. Now, as I've explained you earlier, if you want to move the motor forward, then the condition for that is high-low. So, if I want to move the left motor forward, then I will write high on pin number 3 and low on pin number 4. Similarly, if suppose I want to move the right motor backward, then I will write low on pin number 5 and high on pin number 6. So guys, I hope from this video you would have understood what is an edge bridge and how we can use the edge bridge to control our DC motors. So after understanding the working of motor driver, it is now time to connect the Arduino to the motor driver. First, I'll take 4 male to female wires for connection of motor driver to the Arduino. Now, for programming the robot, I'll be using pin number 3, 4, 5 and 6 from the Arduino. So I'll attach the male part of the wires to Arduino's pin number 3, 4, 5 and 6. Next, I will attach the other end of the wires to the input pins of the motor driver, that is D1, D2, D3 and D4. So, I'll connect pin number 3 from the Arduino to the D1 pin of the motor driver. Pin number 4 will be connected to the D2 pin. Pin number 5 will be connected to the D3 pin. And pin number 6 will be connected to the D4 pin of the motor driver. After this, I'll attach the DC motor wires to the M1, M2, M3 and M4 sockets of the motor driver. In the M1 and M2 socket, I'll attach the left motor wires. In the M3 and M4 socket, I'll attach the right motor wires. Now, for supplying power, I'll be using a battery snapper along with a DC jack connector. And as you can see, the DC jack connector has one positive socket and one negative socket. This is the positive socket where plus is written, and this is the negative socket where minus is written. So I'll connect the red wire from the battery snapper to the positive socket and the black wire to the negative socket. And once this connection is done, I'll attach the battery snapper to the DC jack of the motor driver. So guys, I've basically finished the connection of motor driver to the Arduino, and once you are finished with the connection, let's start with the programming. Hey, what's up guys, welcome back. In this video, we will write the program for moving a robot. Now, since a robot has two motors, that is a left motor and a right motor, we have to move both the motors in order to move the robot in different directions. So, in this video, we will write the program for moving the robot in the forward direction. So first, I'll delete these comments in the void setup. Now, in the previous videos, we have basically done the connection of our Arduino to the motor driver, and we have connected the pins in such a way that pin number 3 and 4 will control the left motor and pin number 5 and 6 will control the right motor. So inside the void setup, I will first define those 4 pins. So I will write pin mode 3, output. Next I'll copy this line 4 times and I'll change pin number 3 to 4, 5 and 6. Next I'll just write a small comment over here. So for pin number 3 and 4, I'll write here left motor, and for pin number 5 and 6, I'll write here right motor. So my void setup code is complete. Next I will move inside the void loop. Now inside the void loop, since I want to move the robot in the forward direction, so to move the robot in the forward direction, I need to move both the DC motors in the forward direction. And if you guys remember, for moving the robot forward, the condition is high, low. That is, I will write high on one pin and I will write low on the other pin. So in the void loop, I'll first write digital write 3, high, and then digital write 4, low. Similarly, if I want to move the right motor in the forward direction, I will again write high on pin number 5 and low on pin number 6. Next, if you want, you can put a short delay over here. I will just put a short delay of 2000. But even though we have given a delay of 2000, this delay will not execute, because when we run the program, since the program is in a void loop, the program will come to the last line, that is delay 2000, and again it will start executing from the top. So this program will keep on executing again and again, and in this program our motors will continuously move in the forward direction. So guys, I basically finished with the program. If I run through the program once, in the void setup I've defined 4 pins, 3, 4, 5, 6. Pin number 3 and 4 for the left motor, pin number 5 and 6 for the right motor. Next, inside the void loop, I am writing high on pin number 3 and low on pin number 4, thus making the left motor go forward, and I am writing high on pin number 5 and low on pin number 6, so that the right motor also go forward, and when both the motors go forward, my robot will thus go forward. Now guys, even though we have finished writing the program, please do not upload the program on the Arduino, because when you upload the program on the Arduino, you will get 3 different types of output. What are those outputs? I'll be explaining you in the next video. So first I'll click on verify to check for errors. So I'll save this program. I'll give this a name of time control robot, and then I'll hit save. So guys, as you can see, the program is compiled and there are no errors in the code. Now in the next video, I'll show you what are the 3 different types of output that you will get. Now, in the previous video, we have written the program for moving a robot in the forward direction, but we haven't uploaded the program in the Arduino yet. The reason why I haven't uploaded the program is because after uploading the program in your robot, you will get 3 different types of output. In the first case, both the motors will go forward. In the second case, one motor will go forward and the other motor will go backward. In the third case, both your motors will go backward. Now, let me explain you why do we get these different types of output. So guys, when we connected the DC motor wires to the output socket of the motor driver, during that time we have just connected the 2 wires of the motor to the 2 holes of the motor driver circuit. The DC motors that we have consists of one positive pin and one negative pin. Similarly, the motor driver also consists of one positive socket and one negative socket. Now, if you have connected the positive wire from the DC motor to the positive socket of the motor driver and the negative wire of the DC motor to the negative socket, then when we write a command for going forward, that is high-low, the robot will go forward. But if you have connected the negative wire of the DC motor to the positive socket of the motor driver and the positive wire to the negative socket, then when you write a command of high-low, instead of going forward, the motors will go backward because the polarities are interchanged over here. So guys, before you upload the program in the Arduino, please lift the robot in such a way that the wheels are not touching the ground. And after uploading the program, just check which motor is going forward and which motor is going backward. Now, as per case 1, if both the motors are going forward, then you do not have to make any changes because you have connected the positive wire of the DC motor to the positive socket of the motor driver and the negative wire to the negative socket of the motor driver. According to case 2, if one of the motor is going backward and the other motor is going forward, then just check which motor is going backward and then you have to interchange the wires of that particular motor. Now guys, as you can see, since the left motor is going backward, I will interchange the wires in M1 and M2 socket. So I will remove the M1 wire and connect it to M2, and I will remove the M2 wire and connect it to M1. From the last case, if both the motors are going backward, then I will remove the M1 wire and connect it to M2. I'll remove the M2 wire and connect it to M1. Similarly, I will remove the M3 wire and connect it to M4. And I will remove the M4 wire and connect it to M3. After explaining you this logic, I will now upload the program and check the output. So guys, as you can see, after uploading the program, my robot motors are basically going in the forward direction, so I do not have to make any changes in the wire connection. And these motors will run continuously forward since we have written the program in a loop. Now, after checking the output, it is now time to set the robot free from the USB. So I'll first remove the USB. Next, I will connect the second battery sniper to the Arduino's DC jack connector and connect it to a 9V battery. So this time my robot will be powered by a 9V battery instead of the USB. Next, I will switch on the motor driver, and as you can see, my robot has just gone ahead. Hey, what's up guys, welcome back. In this video, we will write the program for moving the robot in the backward direction. So guys, in the previous video, I showed you the 3 possible outputs that you will get. So by the end of this video, the robot will move in the forward direction first for 2 seconds and then it will move in the backward direction for 2 seconds. So guys, if I want to move my robot in the backward direction, then I will write a condition of low on one pin and I will write a condition of high on the second pin. So after this delay 2000, I'll write digital write 3, low, digital write 4, high. So my left motor will now go backward when I write low on pin number 3 and high on pin number 5. Similarly, to make the right motor go backward, I will write digital write 5, low, and I will write digital write 6, high. And at the last, I'll put a delay of 2000. So guys, as you can see, I've basically finished with the program for moving the robot in the backward direction. So first, my robot will go forward for 2 seconds. After that, my robot will go backward for 2 seconds. And over here, I'll write a small comment. And the second piece of code is for going backward. Once I'm finished with the code, next I'll click on compile to check for errors. So as you can see, there are no errors in the code. After this, I'll click on upload to upload the program. Hey, what's up guys, welcome back. In this video, I'll explain you the different types of turns that a robot can take. Now, since a robot is a two-wheel robot, there are two types of turns that this robot can take, and these turns are called as axial turns and radial turns. So first, we will talk about what is an axial turn. In axial turn, one motor of the robot goes forward and the other motor of the robot goes backward. Now, if you want your robot to take an axial left turn, then the left motor should go backward. That is, we will write a condition of low-high on the left motor, and the right motor should go forward. That is, we should write a condition of high-low on the right motor. Similarly, if you want your robot to take an axial right turn, then the right motor should go backward, that is low-high, and the left motor should go forward, that is high-low. Now, after understanding axial turns, next let's look at radial turn. So, in radial turn, one motor of the robot will stop and the other motor of the robot will move. Now, since in radial turn, we have to stop one motor and move another motor, the motor that is stopped acts like the center of circle and the moving motor acts like the outermost part of the circle. And since the distance between both the motors represent a radius, that's why we call this turn as radial turn. Now, if you want your robot to take a radial left turn, then the left motor will stop. That is, we have to write a condition of high-high or low-low on the left motor, and the right motor will move forward. That is high-low. Similarly, if you want your robot to take a radial right turn, then the left motor will go forward, that is high-low, and the right motor should stop, that is high-high or low-low. So guys, I hope from this video you would have understood the different types of turns that a two-wheel robot can take. Hey, what's up guys, welcome back. In this video, we will write a program for taking axial turns. So, if I want my robot to take an axial turn, then one motor should go backward and another motor should go forward. So, first I will write the program for taking axial left turn. For taking axial left turn, I will move my left motor backward and I will move the right motor forward. So, after the backward program, I will write over here digital right 3, low and digital right 4, high. So my left motor will go backward. Okay, I just made a small mistake over here. Okay, after that I'll just copy these two lines. I'll paste it here. Now, since I want to move the right motor forward, so for moving the right motor forward, I will now write 5, high and 6, low. So using this 4 lines of code, my robot will take an axial left turn. After that, I'll put a short delay of 1000 seconds. Next, I'll copy these 5 lines of code and I'll paste it over here. And now I will modify this code so that my robot will take an axial right turn. So if I want my robot to take an axial right turn, then in axial right turn, I'll move the left motor forward and I'll move the right motor backward. So for moving the left motor forward, I'll write high on pin number 3, low on pin number 4, I'll write low on pin number 5 and high on pin number 6. Similarly, I'll put a comment over here, axial left turn, and this will be axial right turn. So guys, I basically finished with the program. So now my robot will take axial left and right turns for 1 second. Next, I'll click on compile to check for errors. So as you can see, there are no errors in the program. After that, I'll click on upload to upload the program. Hey, what's up guys, welcome back. In this video, we will write the program for taking radial turns. Now, in radial turns, we basically stop one motor and we move the other motor. So first, I will write the program for taking a radial left turn. And I will remodify this axial left turn program to get the radial left turn output. Now, since I want to take a radial left turn, I will stop the left motor and I will move the right motor forward. So to stop the left motor, I will write low low on pin number 3 and 4, and I will keep the code of high low as it is, okay, so that my right motor can go forward. Next, I will change the comment to radial left turn. After this, I will write the program for taking a radial right turn. So in a radial right turn, we will move the left motor forward and we will stop the right motor. So from this code, I will change the last line of code which says 6, high, and I'll make this 6, low. So I'll copy the radial text and I'll paste it here. So guys, I basically finished with the radial left and radial right turn program. But I won't click on the compile button directly over here, because if I click on the compile button, then the Arduino IDE will overwrite your previous program. So I basically want to keep the axial turn program as well as the radial turn program. So for that, I'll first click on File, I'll click on Save As, and then after the time control robot, I will just extend it by saying radial turns. Okay, and then I'll click save. So now if you see, in this time control robot program, I have written the program for going forward, backward and taking axial turns. And in this time control robot radial turns, I have written the program for going forward, backward, taking a radial left turn and taking a radial right turn. Next, I will now click on compile to check for errors. After this, I'll click on upload. Hey, what's up guys, welcome back. In this video, we will write the program for stopping the robot. Now, if we want to stop the robot, then we have to write a condition of high on all the 4 pins, or we have to write a condition of low on all the 4 pins. So first, I'll copy this piece of code, that is the radial right turn code, and then I'll paste it here. And now, since I want to stop the robot, I will write low on all the 4 pins, and instead of giving a delay of 1 second, I'll give a delay of 5000. If you want, you can also write a condition of high on all the 4 pins and check the output. So guys, I've basically finished with the stop program. So next, I will just comment over here by saying stop. After this, I'll click on compile the program to check for errors. So as you can see, there are no errors. Next, I'll click on upload. Hey, what's up guys, welcome back. In the previous video, we have written the program for stopping a robot. But when we check the output, so during that time, the robot was going forward for 2 seconds, it was going backward for 2 seconds, it was taking a radial left turn for 1 second, a radial right turn for 1 second, and then the robot stopped, but it only stopped for 5 seconds. And after the robot has stopped, it again started executing this program from the top, because this program is written inside a void loop. Now guys, if you want to permanently stop your robot, or if you want to execute this entire program of forward, backward, left, right and stop only once, then I will first cut this code. I'll cut it. So as you can see, I've cut the entire code from the void loop. Next, I will paste that piece of code inside the void setup. So guys, always remember, whenever you write any code inside the void setup, then that code will execute only once. And now if I run through the entire code once, so you can see over here, in the void setup, I have declared the 4 pins 3, 4, 5, 6 as output. Next, I'm moving the robot forward for 2 seconds, backward for 2 seconds. The robot will take a radial left and radial right turn for 1 second. After that, the robot will stop for 5 seconds, but since this program is written inside the void setup, the robot will basically stop permanently. And guys, at the last, as you can see, my void loop function is totally empty over here. So next I'll click on verify. So as you can see, the compilation is done. There are no errors in the program. After that, I'll hit upload. Hey, what's up guys? Welcome back. In the previous video, I showed you how to permanently stop the robot by writing the entire code in void setup. Now guys, in this program, I'll show you how to declare a function and how to call the function. In this video, I'll also show you how to stop a robot by using a different technique. Now, before we declare or call a function, let me tell you why it is important to use functions in programming. So, if you look very carefully, currently my program has 5 particular conditions. First condition is forward, second condition is backward, third condition is radial left, fourth condition is radial right turn, and the last condition is for stop. Okay. Now, let's take a very simple example. Now, if suppose you want your robot to trace a square, then your robot should move something like this. It should first go forward for some second, then it should take a left turn. After that, it should again go forward for some seconds. Then it should again take a left turn. It will again go forward for some second. It should again take a left turn. And at the last, it will again go forward and it will stop at the starting position. Okay. So this is how your robot can trace a square. One way to write this program is you can write the forward condition of high low 4 times, and you can write the low high low condition to take left turn 3 times, and the last condition will be to stop the robot. That is, all the 4 pins will be high or all the 4 pins will be low. But if we write the program in this manner, 4 conditions for forward and 3 conditions for left turn and 1 condition for stop, then the program will become very lengthy inside the void loop, and if the length of the program increases, the size of the program will also increase. This is not an ideal way to write any sort of a program. So basically, I'll create a new function called as forward, and I'll paste all these 4 lines inside that forward function. Similarly, I'll create new functions for backward, radial left, radial right, and for stop condition. So let's get started with the programming. After the void loop, that is outside the void loop, I'll first create a new function. I'll give it a name of void forward. Then I'll open and close a round bracket. After that, I'll open and close a curly bracket. Now this code that we have written of void forward is called as function declaration, or we can also call it as function definition, because we are defining a function over here. So I'm declaring the forward function just as we have declared the void loop and void setup function. Now inside this function, I'll write some code, and that code is to move the robot forward. So I'll cut this piece of code and I'll cut only the 4 lines of high low. Okay, I'll paste it here. Next, I'll delete this delay. Okay, I'll tell you later on why I'm not using the delay. Next, I'll cut this code. So I'll press Ctrl X. And I've not created or I've not declared a void backward function. So I'll declare a void backward function first. Next, I'll paste the backward condition in this. After that, I'll cut the radial left turn condition. I'll declare a radial left function and I'll paste the code for radial left turn. Next, I'll cut the radial right turn condition. I'll declare a function called as radial right. I'll paste the radial right turn condition over here. And at the last, I'll go in void setup again and I'll cut the condition for stopping the robot. I'll declare the void stop function over here. Okay, now guys, if you notice one thing very carefully, that when I was declaring void forward, void backward, void radial left, and void radial right function. So during that time, all these functions are in black color and this void stop function is in orange color. So that basically means the stop command could be a predefined command or it could be some predefined function. Okay, so instead of using the word stop, I'll use some other word. So I'll use a word called as time stop, and inside the time stop, oh sorry, I've actually cut the stop condition, so I'll paste it again over here. Okay, and next I'll go in the void setup and I'll delete all the delay commands over here. Okay, I'll press backspace now. Now first, let me tell you why I have not put the delay command over here. Now, if I put the delay command in all the 4 conditions, and if you call the void forward function over here, then basically what will happen is, since this void forward function has a delay of 2000 milliseconds, that is 2 seconds, then the robot will only go forward for 2 seconds. So that's why I haven't put any delays inside the functions, because we can declare the delays separately. Now guys, after declaring the functions, next it's time to call the functions, and we will call these functions inside the void loop. So guys, as I discussed earlier, if you want your robot to trace a square, then it should first go forward. So inside the void loop, I'll first call the forward function, and to call the forward function, I'll just write forward. I'll open and close round brackets, and at the last, I'll put a colon over here. Okay, so when you write this term forward by opening and closing a round brackets after it and then putting a semicolon, then that basically means you're calling the forward function inside the void loop. So now inside the void loop, first high-low condition will execute, but since we want to trace a square, next I'll put some delay below the forward condition. So I'll give this a delay of 2000. Okay, so let's put a delay of 2000. After forward, I need to take a left turn. So for the left turn, I've declared a radial left function, and this is the function name of radial left. So I'll copy this function name. I'll press Ctrl C, and then I'll paste this function exactly below the delay. So now after delay 2000, I'm calling the radial left function. Now since I'll be taking a turn, so for taking a turn, the delay, there is no need to put a delay of 1000. I can just put a delay of 700. Okay, now you can try experimenting with a delay unless and until you get a proper 90-degree turn. Now after taking a left turn, I again need to move the robot forward. So I'll copy this code for forward because I'll be using it again and again. So after taking a left turn, I'll copy the code for forward. Next, I'll put a delay of 2000 again. After that, I'll again copy the radial because this will be my second radial left turn. Now guys, after taking this radial left turn, I'll again need to move the robot forward. So I'll write forward again, and I'll put a delay of 2000 over here again. Okay, I think typing the code is better than copying it. Next, I'll again write radial left. So I'll again call the radial left function. I'll put a delay of 700. And next, this will be the last forward condition in which my robot will be moving. So I'll again give this a delay of 2000. Okay. Once the robot executes the last forward condition, I'll basically stop the robot. So to stop the robot, I'm using a function called as time stop. So I'll copy this function, that is time stop. I'll call this function exactly after the delay 2000. But guys, here's one more problem. I'm just declaring the time stop function at the end of the void loop. Okay, so even if I put a delay of 5000, the robot will only stop for 5 seconds, and after that the robot will again start executing the forward condition. So in this case, the robot will actually stop at the starting position of the square. That is, over here, it will stop at the starting position of the square, and once it stops at this position, the robot will again start moving forward. Okay, and this is something which we do not want to happen. So guys, as I told you at the start of the video, I'll also be showing you an alternate method to stop the robot. And that alternate method to stop the robot is by setting a delay of infinity. So after the time stop function, I'll set a delay and I'll set this delay as infinity. So for infinity, I'll set the delay to 1/0. Okay, as 1/0 is an equation for infinity. So guys, basically when your robot executes the last forward condition of 2 seconds, it will stop at the starting point of the square, and this time the robot will stop infinitely, that is, it will never start again. So guys, I basically finished with this programming. If I go through this program once, so in this program we are actually moving the robot in a square. Now first I have declared the void setup. I have declared 4 pins 3, 4, 5, 6. Next I am declaring 5 functions: forward, backward, radial left, radial right, and time stop. After that, since I want to move the robot in a square, I'm first moving the robot forward for 2 seconds, then I'm taking a radial left on for 0.7 seconds. Next, I'm again moving the robot forward. Next, I'm moving it left, forward, and then I'm using a delay of 1/0 with the stop function to stop the robot permanently. Now, after explaining you this program, next I'll save this program. So I'll click on File, I'll click on Save As, and I'll give this program a name of Time Control Robot Square. The reason why I did Save As is because I did not want to overwrite the Time Control Robot Radial Turns program. So once I'm done with this, next I'll click on Compile to check for errors in the program. So as you can see, there are no errors, and at the last I'll click on Upload. I hope you would have liked this free video, which is a part of my hands-on robotics course, which is a best-selling robotics course on Udemy. With more than 4.5 hours of robotics content, you can understand why more than 20,000 students from 152 countries have already enrolled in this course. In this course, you will develop 13 different robotic projects using Arduino, which includes PC controlled robot, smartphone controlled robot, accelerometer controlled robot, voice controlled robot, black line follower, white line follower, light repeller, to name a few. The hands-on robotics course is currently priced at $150, but as a subscriber of this channel, you can get it at a discounted price of just $10 by clicking on the link in the description. Check the promo video first, and if any of the project interests you, then you can take your decision on whether to purchase this course or not. So guys, if you like this video, please hit the like button and subscribe to my channel for more amazing videos like these.